Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to calculate the probability of at least one using example problems. Let's get started. First, let's look at disk defect rate. So we have a manufacturer of data DVDs. And the manufacturer supplies these DVDs in lots of 50. They've also reported a defect rate of 0.5%, so the probability of a disk being defective is 0.005. It follows that the probability of a disk being good is then 99.5%. So the question we're asked is, what is the probability of getting at least one defective disk in a lot of 50? Go ahead, pause the video here. See if you can work this problem on your own, and then come back and we'll see how well you did. Okay, let's see how well you did. So the probability of at least one is 1 minus the probability of none. So the probability of at least one defective disk in the lot of 50 is 1 minus the probability that there are no defects in all 50 disks, that all 50 disks are good. Well, that's going to be the same as 1 minus the probability that the first disk is good times the probability that the second disk is good, all on the way over till you get to the 50th disk. So that 0.995 is going to be repeated in a strain of 50 times, and you're multiplying all 50 of those numbers together. But we can rewrite that as 1 minus 0.995 raised to the 50th power. So now at this point, it's just a matter of punching it out on our calculator. So 0.995 raised to the 50th power is 0.778. We subtract that from 1, and we end up with 0.222. So 22.2% is the probability of getting at least one defective disk in a lot of 50. Let's look at an example involved water testing. Sometimes people who are testing water samples, they'll combine the samples together in order to save money. So here we have biologists testing a mixture of 4 samples of lake water for a particular bacteria. The whole mixture will test negative only if all the samples from the mixture test negative, because you're taking these 4 samples and you're putting them together into one sample, the mixture. So if any of one of those 4 samples contains enough of the bacteria that the biologists are looking for, then the whole mixture is going to test positive. So the only way the whole mixture tests negative is if all the samples that you're using to form the mixture test negative. The question then is, if the probability of a single sample testing positive is 15%, what is the probability of a mixture of 4 samples testing positive? Go ahead, pause the video here, see if you can work this problem on your own, then come back and we'll see how well you did. Okay, let's see how well you did. So first we were looking for the probability that at least one of those samples in the mixture tests positive. Because if at least one of those samples tests positive, then the whole mixture will test positive. Well, the probability of at least one is 1 minus the probability of none. The probability that none of the samples test positive is the same as the probability of all 4 of the samples in the mixture testing negative. And the probability that the 4 samples test negative is just going to be 0.85 raised to the 4th power. 0.85 comes from 1 minus 0.5. This is the probability that the sample tests positive. So the probability that the sample tests negative is 1 minus that. So that's the 0.85. And then raised to the 4th power because we're looking for all 4 samples. From this point, it's just a matter of punching that out on our calculator, which when we do, we get 0.478 or 47.8%. The next question is the probability low enough so that further testing of individual samples is really necessary? I'll give you a moment to come up with your answer. Well, I hope you said, no, the probability is not low. 47% is like almost half. That's huge. So this is no small probability here. So yeah, you're going to need further testing. Let's look at one more example, talking about births in China. Now, for many years, China had a policy of that each couple in China could only have one child. And because traditional Chinese culture prizes male children over female children, you saw a lot of parents who were killing off their daughters because they wanted a son for their one child instead of a daughter. Really horrible what was going on. Recently, China reversed this policy. So now Chinese couples are allowed to have more than one child. But let's say the probability of a Chinese couple having a boy with a single birth is 54.5%. So if we have 6 randomly selected births in China, what is the probability that at least one of those 6 newborns is a girl? Go ahead, pause the video here, then work this problem, come back, and we'll see how well you did. Okay, let's see how well you did. So the probability that at least one of these 6 births is going to be a girl is going to be 1 minus the probability that none of them are girls. And the probability that none of them are girls is the same as the probability that all 6 of them are boys. So what's the probability that all 6 of them are boys? Well, that's going to be the probability of having a boy, which is 54.5%, raised to the 6th power, because we're looking for 6 boys. We punch this out on our calculator, and out comes 0.974. So there's a slightly higher than 97% chance that at least one of those 6 births will be a girl. The next question is, could this system continue to work indefinitely? Go ahead, pause the video here, come up with your answer, then come back and we'll see how you did. Okay, let's see how you did. Could this system continue to work indefinitely? Well, the answer is no, it's not going to continue indefinitely because the probability of having a boy is greater than 50%. So if you just take that on to its logical conclusion, you're going to have more and more boys in time and fewer girls. Well, if you have more and more men and less women, eventually you don't have enough women to birth the children you need to support a growing population, to produce that next generation so that your population is not diminishing. So the answer is no, this system would not continue to work indefinitely. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.